This video is going to be on graphing a parabola of the form y equals ax squared plus bx plus c with integer coefficients. Remember, coefficients are just the numbers that are in front of the variables, and integers just mean negative or positive or zero whole numbers. So any counting numbers, including the negative numbers, all the way up to infinity. All right, so graphing a parabola in this form, remember this form is what we call standard form. So standard form basically means that the x squared goes first, then the x term, and then lastly the c or the constant. Sorry, that's a little sloppy, but this is called standard form, okay? So I'm gonna erase all this and then let's read this and see what we're asked to do. So we're gonna go ahead and graph the parabola, and here's the equation of a parabola. We know it's a parabola because the highest degree or the highest order is x squared, right? So that's gonna make it have a parabola shape. Either it's going to look like this, or it's going to look like an upside down UV shape. Now, we actually know which way it's going to face, if you recall, because of the coefficient of the square value. The coefficient is negative, so it's going to look like this one. When it's negative, it opens down. When it's positive, it opens up, because what happens is the negative flips all of the inputs. When it comes out as an output, it's going to head down. All right, so our parabola is going to look something like this. Plot 5 points on the graph of the parabola. The vertex, remember the vertex is the turning point, 2 points to the left of the vertex and 2 points to the right. Then click on the graph of function button. Now I don't have the graph of function here, so I'm just gonna make a table to show you how to do this so that once you're ready, you can graph that function. So let's go ahead and let's first find the vertex, okay? So how do we figure out where that point is? Well, there's a formula to find the vertex, and it's based on this value here, the coefficient of the x and the coefficient of the of the x squared. So this is our a value, this is our b value, and this is our c value according to the standard form, right? A, b, and c. So let's go ahead and let's write over here what is our a, our b, and our c values. The a value is right here in front of the x squared. Since there's no number, it is just a -1 because there's -1 x squareds. So a is -1. B is this number in front of the x, which is +8. And our c value is -20. Notice we're using the sign in front of the coefficient. All right, so it's really important. This is where a lot of people make mistakes, is not including the sign here. Now, in order to find the vertex, we want to use the formula for the axis of symmetry. Remember, the axis of symmetry is just where that vertex goes through. It cuts the parabola into 2 equal parts, so it's like a reflection of itself. So in order to find the axis of symmetry, we use the formula x equals -b divided by 2a. All right, well, we know what a and b are, so we can find x. -b would be -8, right? From right here. Divided by 2a, and we said a was -1. Those are parentheses. So this is -8 divided by -2 times -1, which is -2. Well, a negative divided by a negative is a positive, and 8 divided by 2 is 4. So this tells us that 4 is going to be the center of the parabola. So when we make our table, let's try that again. When we make our table, we're going to want to put 4 at the center of that table. Okay, I'll just do 3 points so that you can get the idea of it. All right, so we're going to see what we get. We're going to input our x value and get out our y value. I'll write it as an ordered pair over here. And then here we'll show our work, okay? Let's write that a little nicer. Okay, so here will be our work. So what we did to find the vertex is we want to see what the center is, right? Since the center is 4, I'm going to put it in the middle. And then I want to try 2 points to the left and 2 points to the right. So I'll just try 1 point to the left and 1 point to the right. But when you're doing this, you're going to want to also try 2, because that's a further point to the left, and 6, because that's a further point to the right. I'll just show you with 2 points on either side. So what we're going to do is we're going to plug in each of these values to the same equation for x and see what we get out for y. So when we're plugging in a positive 3, we would get negative, parentheses 3, because that's our x, squared, plus 8x, so plus 8 times 3, minus 20. Okay, now I'm going to do a little bit of mental math here. Negative 3 squared, first you do the exponents because these parentheses are just multiplication. There's nothing to do inside the parentheses. So this would be a negative 9 plus, let's see, 8 times 3 would be 24 minus 20. And it doesn't matter what order we do this in because this is all addition and subtraction. So I would probably do 24 minus 20, which is 4, and then minus 9, which would give me a negative 5. All right, so when we plug in a 3, we get out a negative 5. So this is going to be 1 point on this parabola. Let's go ahead and do that for the positive 4 now. So it's negative x squared. I'm just writing the same thing, but wherever I see a 3 for the x that I plugged in, I'm putting in a 4 now instead, right? Because it's the same equation, still that parabola. But now I'm seeing, what do I get for my output when I input is a 4? So let's see, 4 squared would be 16, so this would be negative 16 plus 32 minus 20. So negative 16 plus 32, that's positive 16, minus 20 would give me a negative 4. So negative 4 is my output when I put in a positive 4. And last but not least, let's plug in a 5 and see what we get. Plus 8x, so 8 and x is 5, so that times 5, minus 20. All right, I'm going to do this one in my head a little more. 5 squared is 25, so negative 25 plus 40, because 8 times 5 is 40, minus 20. Well, 40 minus 20 is 20. And 20 minus 25 would give me negative 5. And if you'll notice, it's the same thing that I got on the other side of the vertex. So if you're picking a number that's the same spaces away, like 5's 1 space away from 4, and 3's 1 space away from 4, then you should get the same value for both of your outputs. So let's just go ahead and sketch this really quick and make sure that it fits what we said in the beginning. 3, negative 5. Let's draw a quick coordinate plane. Let's see. 3, negative 5 would be around here. And then 4, negative 4 would be a little bit higher, right? And then 5, negative 5 would be going back down again. And if you'll notice, that is following the shape that we said it was going to take, right? It's following this negative orientation, or what we might call concave down. So you're going to go ahead and graph this. Hopefully this helps you graph a parabola in standard form.